Welcome to my presentation on 5 statistical concepts to build meaningful dashboards. This is designed mainly for small to medium-sized businesses. It is an exploration of how AI dashboards, which are very generic, fail to capture some of the underlying nuances of the data, especially for small businesses. I'm hoping that this also helps people who are in the data teams that work at small to medium-sized businesses. If nothing else, they can know what they need to tweak in their AI-driven or machine learning-driven tools for higher accuracy. This is an example of a generic dashboard, built using data from Excel sheets. There are a lot of AI tools like this on the web now. I just used one of them and decided not to reference which one because I don't want to pick on any specific tool. This dashboard is supposed to show sales performance and product revenues. You can see that for 2018 data, it gives the trend lines the number of new customers. It also provides revenues and profits funnel for sales by contact method as well as top products by revenue. However, it doesn't really give any insights into what a business owner can do with this data other than just look at it. Generic dashboards are built on expectations instead of hypotheses, and the KPIs follow legacy preferences instead of vision. Data models are often misaligned in the context that a small business might want to use it, and the causality mapping of data is weak or missing. Summarized views are preferred over aggregate details. And that's where the nuances lie. There are 5 basic statistical concepts that need to be adopted by SMBs or enterprises alike. The first one is central tendency measures like mean, median, mode. The second one is dispersion from average. Correlation coefficients and finding their significance is the third one, followed by time series analysis. The fifth concept is using confidence intervals for forecasting. These are things that are often missed in the dashboards in a clear way. That is the goal of my presentation today. To show how things like mean, median, mode can be used for finding and identifying the trends, the skewness, and the performance of any series of data. In my dataset, I have daily revenues, daily profits, and daily profit margins that have been calculated based on revenues and profits. As you can see, this is my version of what I would put in a dashboard if I was creating one. The revenues are skewed and so is the profit, but the daily profit margins are not as skewed. The big thing to remember is that when there's skewness, there might be higher or lower values that are pulling the data or the mean, the average in one direction or the other. And this is why we do need to use both median and mean to find out if there is any heavy skewness that we need to consider in our data series. Thereafter, we move on to central dispersion, which is where we look at standard deviation and interquartile range. Interquartile range hovers around the median. It is the middle 50% of a data set. On the other hand, the standard deviation shows where the average or the mean lies and then the movement from the mean for any given day. That is the logic upon which the distribution is built. 67% of the time a given value on a given day is going to fall within one standard deviation from the mean. Thus, if the mean is 19,000 and the deviation is 11,000, then 19 minus 11 is about 8. So the lower limit of the interval is 8,000 and the upper limit is 30,000. In regular words, we can say that the revenues are between $830,000 on 67% of the days of the year. On the rest of the days you could have lower or higher values. For the middle spread or the IQR analysis, we look at the middle 50%, which means that 25% of all days are going to perform below that range, and 25% are going to perform above that range. Having words in a dashboard matters because that's where a reader can figure out what these numbers mean, and this is often missing from many dashboards. The third statistical concept is the correlation coefficient. In the series I used, there was not a lot of available data on costs. A lot of people would assume that quantity sold and profit margins should be related to each other. So, I decided to try to check if there was any correlation between the two. Since the cost data is missing, I found this really interesting pattern that there is no correlation between total weekly quantity sold and weekly profit margins in percentage terms. But here's the thing. Correlation only captures the linear relationship between two variables. It is entirely possible that this relationship is nonlinear or is being impacted by something else. So choosing to say whether correlation and causality are hand in hand or not is a fallacy. Correlation is different from causation. Correlation only looks at linearity, and does not necessarily imply or fail to imply causation. So causation has to be considered separately in order to find out how these series are moving. Moving averages are often used by businesses either monthly, weekly, whatever the case may be. And you can see on the left-hand side that while the moving averages smooth out the curve, the predictions could be uncertain in a lot of cases. Especially if you look at the profit margin, you'll see that the red line barely smooths out the blue line, but doesn't really explain enough to be relied upon, going forward. When we build actual models using regression analysis, we start getting more robust modeling. If you see on the right-hand side, you will see that the red line is the predicted regression line and it is far closer to the existing values than we found with the moving averages. So we can move to more sophisticated methods depending on how much data we have. This was 52 weeks of data that I aggregated. Once we have a model selected, our forecast is reliable but still not precise enough to show 100% confidence. That's why we use confidence intervals. They show the ranges within which we can be up to 95% confident about our predictions. For instance, in the coming 8 weeks revenues are going to fluctuate in that little green zone and not exactly on that blue line. The whole point of creating these charts is to highlight that analysis goes hand in hand with relevant insights. Just throwing the analysis up on a dashboard is insufficient and lacks context. So well-designed dashboards can actually make a difference. Effective dashboards should build on meaningful statistical analysis. They should clearly communicate any uncertainties and risks. Understanding the data distribution, testing assumptions, validating the model on a frequent ongoing basis is critical, and these metrics can be improved upon by the data teams that are already at your business. This is just an example of what is possible and what can be done. A meaningful dashboard with actual insights within it can be extremely helpful for decision makers. If you are a decision maker at an SMB looking to create meaningful dashboards, send me an email and let's talk data.